Okay, guys, so we're in Unit 2, and we're in Inductive and Deductive Reasoning, and we're basically going to be talking about patterns, and it's a lot of words in geometry in this portion, so we're going to talk about, basically patterns first. So inductive reasoning is reasoning based on patterns you observe. So when we look at this, and we did this in algebra, what are the next two terms in the sequence? Well, obviously we're subtracting by 5 in A, and so the next two terms are 25 and 20. In B, we're multiplying by -2 every time. And so the next two terms are 64 and -128. In C, we're subtracting by 1/2 every time. So 6 minus a half is 11 halves, minus a half is 5, minus a half is 9 halves, minus a half is 4, minus a half is 7 halves, minus a half is 3. So a conjecture is basically the math term for hypothesis. The conjecture is our educated guess based on the pattern. So if I have this cycle down here, what can we guess about the 21st term in the cycle of RWB? So if I have RWB, it keeps repeating itself. And there are 3 letters in the pattern before it starts repeating. And so R is the 1st, 4th, and 7th. W is the 2nd, 5th, and 8th. And B is the 3rd, 6th, and 9th. So can you figure out what the 21st term is going to be? I want you to pause the video for a minute and see if you can figure out what the 21st term is going to be. Okay, the 21st term is going to be B because the pattern repeats itself 3 times. Now, in algebra and geometry, we can do other things based on patterns that we observe in algebra. And so if I take odd numbers and I add them together, they actually create a pattern. So the first odd number is 1. When I add 1 to itself, I get 1. That's equal to 1 times 1. The first 2 odd numbers are 1 plus 3. That equals 4. When I look at 4, that's 2 times 2. The first 3 odd numbers are 1, 3, and 5. When I add them together, I get 9. That's 3 times 3. The first 4 odd numbers are 1, 3, 5, and 7. When I add them together, I get 16. That's 4 times 4. The first 5 odd numbers are 1, 3, 5, 7, 9. When I add them together, I get 25. That's 5 times 5. So by now, do you understand a pattern? The pattern is for any number of odd numbers that I have, that's equal to the number times the number when added together. So what would be the sum of the first 30 odd numbers? Hopefully you realize that the sum of the first 30 odd numbers is equal to 30 times 30. And so you've gotten 900. Looking at this right here, what is a good guess for the number of backpacks that are going to be sold in June? Is it going to be more or less than 8,000? Looking at the graph, you would say that the number of backpacks sold will be less than 8,000. So again, it's just looking at a pattern. Okay, in order to do this the most efficient and correct way, you like to have at least 3 examples. So if you notice up here above, we had 5 that got us to our pattern. If you notice in the trend data, we had 6 data points that told us that June was going to be less than 8,000. So what I want to do is I want to look at some example math situations and see if we can get a pattern going. So the sum of 2 odd numbers. So if I add 1 plus 3, I get 4. If I add 3 plus 5, I get 8. Okay, so an odd plus an odd is equaling an even. Let's try one more. Let's do 1 plus 7. That's also 8. So our conjecture is that an odd plus an odd is going to equal an even every time. I want you to take a look at B and C and see if you can tell me a conjecture based on the product, which means the multiply, of 2 even numbers and 1 odd and 1 even number. Pause the video, try those out, and come up with a conjecture. Okay, hopefully you realize that an even times an even would always equal an even, and then also an odd times an even would always equal an even. And so that is the conjecture for that information. The last vocabulary word that we need for this lesson is counterexample. A counterexample is one example that proves a statement false. And sometimes those counterexamples can be words, or sometimes those counterexamples can be a drawing. So, for example, if a flower is red, it is a rose. Can you think of a flower that is red that is not a rose? Okay, hopefully you said something like carnation, tulip, some other flower. You could have also proven this false because are all roses red? No, some roses are pink, some roses are yellow, some roses are white. So there's lots of different colors of roses. So there's 2 different ways to prove this statement false. Okay? Now, for example B, we're not going to be able to do anything except for draw a picture, because it says if angle ABC and CBD form a linear pair, then angle ABC is congruent to angle CBD. So in order to find a counterexample, we have to draw a picture that proves this false. So let's see the first perspective of, okay, our 2 angles form a linear pair. If we were going to draw them congruent, we'd have to draw this straight up and down, correct? But we're not, because this is a counterexample. So now ABC is not congruent to CBD. So that's our first example that proves the statement false. Now let's go to the idea of, okay, well, only angles that are congruent form linear pairs. Is ABC congruent to CBD? Yes. Is it a linear pair? I think we can definitively say that no, it is not a linear pair. Alright, so I want to make it clear what the assignment is and how this all works together. So when we go to page 35 in our workbook tomorrow, I mean, if you start it now, that's fine, but you might be a little bit bored, so I just want to be clear on that. You're completing 1 through 22 and then 25 through 28. If you can see, it's all about patterns. So 1 through all the way down to 10 matches what we did in the first part of the notes, all the way through to here. Is identifying patterns and terms. Okay? All the way on the front page. 11 through 22 works on the stuff that we talked about on the back. Being able to find a pattern and then apply it to the problem. So, we talk about squares and cubes and products, and, being able to find a pattern and being able to apply it to the problem. So remember, for 11 through 14, you're going to need more than one example to prove what your pattern is. Same thing with 15 through 22. And if you can't find these patterns, it's okay. Some of these are pretty advanced, so just try your best. That's what I'm looking for. Okay. And then when we get to the back, 25 through 28 focuses on this counterexample idea. Find one way to prove 25 through 27 incorrect. And then on 28, I just want to see if you can give me the next two figures in the sequence. So again, it works on the same thing. So as we talked about in Unit 1, my notes follow exactly in line with what I'm asking you to do in the problems. Okay? And then my problems go exactly in line with what I'm going to ask you to do for the quiz and for the test. So understand how this all works together, okay? That wraps up the first lesson in Unit 2. If you have any questions, come see me before class. Otherwise, we will go over this in class tomorrow.